Hello friends, here I will be providing you the question paper solution of BTU June-July 2025 examination of the subject microcontrollers. In this particular session, we will be discussing the module 1 and module 2 related questions as well as solutions of this particular question paper. In the upcoming sessions, I will be taking upon the remaining modules. Let us start with the module 1. The very first question, with diagrams explain the RAM structure of 8051 microcontroller. This is for 8 marks. So in this you have to make a write-up of the RAM representation which starts from 00H and ends with the 7FH. You have to write the diagram in this pattern itself because the representation indicates first set from 00 up to 1FH, it's the register banks. Then starting from 20H up to 2FH, it's the bit addressable memory, and from 30H up to 7FH, it's the general purpose RAM we are going to have. So you have to write this structure and you have to provide the sufficient explanation about all these different types of RAM representations. Question 1b. With necessary sketches explain flags and program status word. Second one, stack operation for 8 marks. Let us first start with the flag and program status word. So this is the 8-bit representation that you have to write, and then you have to explain what each bit is going to represent. That is given in this particular table. Further, the RS0 and RS1, they are going to indicate the register bank select, and this is what the representation for that. So these things you have to write it first. Further, you have to provide few words of explanation. So here is the few words of explanation over here. So what is flag? So each bit is going to indicate a flag, and which are the different types of flag. So math flag, general purpose flag. So how they are being used. So everything you can have a representation over here. So more details about the program status word is being discussed in my YouTube lecture that will be link given over here. Continuing to the stack and its operation. So we must represent what is stack, where it is located, and using which pointer we are going to access the stack. So all these things you have to first make a note of it. So that theory is being given over here. So stack is a part and parcel of the RAM. Stack pointer is used to hold the address of the stack. We call that as the top of the stack. So in the stack pointer increments before storing the data into that we call it as increment and store procedure. Similarly, when we are retrieving the data from the stack, it is first retrieve the data and then decrement the stack pointer. And this is small realization of storing of data onto the stack and retrieving that back to the register or anything, any memory location. So that is what is going to happen in the stack pointer that is being represented over here. 1C. Write a note on embedded microcontroller, this for 4 marks. So you have to make a general realization of what is this embedded microcontroller and what are the types of tasks being performed by making use of this embedded microcontroller. So here is a brief description about that. So an embedded microcontroller is a compact self-contained system in a single IC. So these are other few applications. Key features are being mentioned over here. So where it is being used, the applications are being listed. If you know more applications, you can just add up applications for this one. Now getting into the question 2a. With need diagram, explain the block diagram of 8051 microcontroller. So this is for 8 marks. Solution. So this is the block diagram of the 8051 microcontroller. So which consists of the timer 1, timer 0, then serial control, 128 bytes of RAM, then 4 IO ports, then 4K of ROM, then bus control, then interrupt control, CPU, which will be provided with the oscillator, and in between this is the bus connection we are going to have. So this is the general block diagram of 8051 microcontroller. You have to make use of the explanation to each of these blocks being represented. So that's what the description, and it covers for 8 marks. Now getting into 2B, write an interfacing diagram of 8051 microcontroller interfaced to 16 kilobytes of RAM. This is for 8 marks. So there is no theoretical issue related to this one. So we have to just realize the diagram, and remember here we are just making a connection only to the RAM. ROM is not asked in the question. So we have to make a connection only for that much. So now here it is for 16 kilobytes. So size of the RAM is 16 kilobytes in the sense. So it is equivalent to 2 to the power of 14. That means 14 address lines are required, which starts from 0 up to 30. So total 14 lines are required to address 16 kilobytes of memory. And this is what the diagram we are going to have. So 805 microcontroller, then this is the RAM, and in between we must have a latch in order to store the temporary data, temporary address. Now AD0 to AD7, so this is a common bus both for data as well as the address. Therefore this is being connected both for RAM as well as to the latch. So in the first part, the address will be sent on this bus, which will be stored onto the latch by making use of the address latch enable signal. Then after, this particular bus will be used in order to either to store the data onto the RAM or to retrieve the data from the RAM. So that will become the data bus later. Then continuation of the address line will be from A8 up to the A13. Total A0 up to A13 is what total 14 lines we are going to have. The other two lines we are going to have RD and the write. So this is the write signal where the data from the microcontroller will be written onto the RAM, and RD is the read. So data from the RAM will be read to the microcontroller. The same lines is being read over here as WE, that is write enable as well as output enable. Now to see, compare CISC and RISC architecture. This is for 4 marks. So 9 differences are being listed over here. So you have to remember any 4 differences among these listing. Now getting into the module 2. So question 3a. Write a program segment to copy the value 55H into RAM memory locations 40H to 44H using first one, direct addressing mode, register, indirect addressing mode without a loop, third one, and with loop. Total 3 different programs we are going to have a follow-up of here. This is for 6 marks. So first one, using direct addressing mode. So we have to move a single value, that is 55H, to these locations. So direct addressing mode in the sense address will be directly used within the instruction. So here move 40H comma hash 55H indicates 40H is the memory location and hash 55H is the data. So this data is being moved into the memory location 40H. So like that 41H, 42, 43, 44H. So this is the direct addressing mode. Now register addressing mode without using the loop. So without using the loop, in a sense, each time we have to take a memory location in an indirect manner and then store the data. So that procedure we have to make a follow. Now we are storing the value to the accumulator, then address to the register R0, then move the content of accumulator to the memory pointed by the R0. Then increment R0, again repeat this for how many times until we store the data to 44H. So this is without loop. Now let us get into the with loop concept. Now this is with loop. So move a comma hash 55H, move R0 comma 40H. So this is same as the previous one. Then how many to how many memory locations we have to move. Total 5 memory locations we are storing the data. So R1 comma hash 05H, where it is going to act like a counter operation. Now this is the loop part we are going to have. Move at R0 comma A, contents of A will be moved to the memory location pointed by R0, then increment R0, decrement jump on no 0 R1 comma loop 1. If R1, decrement the R1, if the value of R1 is not equal to 0, then move back to the loop 1. So this is going to complete the storing of value to the memory for 5 memory locations. So this is with loop concept. Now 3b, explain the following instructions with examples. First one, move C A comma at A plus DPTR. Second one, RRC A. Third one, DAA. This is for 6 marks. First one, move C A comma at A plus DPTR. So meaning of this one, the contents of A are added to the 16-bit register DPTR to form the 16-bit address of the needed data. So this what the meaning of this one. So first you have to write down this one and any example they are asking. So here we have created a lookup table and this program has been written using this particular instruction in order to access the contents of this lookup table. So like this you can make a follow-up of any other examples using this instruction. Getting into the RRCA, so rotate the accumulator A register 1 bit position through the carry rightwards. So this is what RRC we are going to have. So this is the general representation. So you have to write this much and then any example. So this is small example we have taken. Move A comma hash 0 A5H. So to the accumulator we are storing the value A5H and then clear carry because this is movement with respect to the carry. So before performing the RRC we are first clearing the carry by setting C is equal to 0. So before this carry value is considered to be something unknown value, therefore it is being written as C is equal to X. So need not to bother about that. So C will be initialized to 0. Further RRC A is being done after executing this instruction. Now this will be the content of the accumulator and the bit of the LSB has moved to the carry. The value of carry bit has moved to the MSB position of the accumulator. So after shifting right this value through the carry, so we are going to have the value this in the accumulator, carry will be equal to 1. And this for the demonstration of this complete process for your understanding. So this is DAA, decimal adjust accumulator. The meaning adjust the sum of two packed BCD numbers found in a register. Leave the adjusted number in A. Procedure you have to understand as well as you have to write for this one. At what condition we have to make use of DAA instruction? Only at 2 cases. Whenever you are using the add instruction or add with carry instruction, after this only you have to make use of the DAA instruction. Now what it is going to do? If the lower nibble 4 bits, the lower 4 bits is greater than 9 or if AC is equal to 1, that is auxiliary carry flag is equal to 1, add 0110, that's the value 6 to the lower 4 bits. Second condition, if the upper nibble is greater than 9 or if CY is equal to 1, that is carry flag is equal to 1, add 0110, that's the value 6 to the upper 4 bits. Now here is an example program we are going to have for this one. So two values we are taking. One is 47 to accumulator, 25 to the B, and we are adding those two values and we are then writing DAA instruction. Now after this we are going to get the value answer in the accumulator as 72. And here is the simple procedure being explained for the same values. How the things are going to happen. 47 we have written, 25 it has been written. So if we add them, basically we are going to get the result in the hexadecimal only, that is 6CH. So based on these two criteria, we are going to identify what has to be done. So in this particular case, we need to add value 6 to the lower nibble. So value 6 is being added, then we are going to get the 72 as the answer, that is equal to the decimal. So that's what this simple illustration of the values which is applicable with respect to this program is being given for your understanding. Now question 3C. Briefly explain the arithmetic instructions of 8051 microcontroller. This is for 8 marks. So all these will come under the arithmetic instructions, but basically we are going to have a detailed study of only these 4 instructions: add with carry, then subtract operation, multiplication, as well as the division. So it is for 8 marks. You have to take each of these 4 instructions individually and provide sufficient explanation, if possible a small example program. So here is the add instruction, which are all the different varieties of add instruction. Make a list of them, and then which are all the flags being affected due to this add instruction, and a small example of the addition. Similarly, for subtraction operation, so what is going to happen in the subtraction, which are all the different varieties, flags being affected, a small example of that. So then multiplication and division. So mul AB is the multiplication operation. So it is being done. So it has been listed over here. You can just go through that. And then with respect to the division, here is the details of the division. So div AB, that means for multiplication and division, compulsory you have to make use of the register A as well as register B only. No other registers or the direct memory locations are applicable for this one. So the data must be present in A and B only. In case of division, so A is going to hold one value and B is going to hold the another value over here, and that is what is being represented over here. So in the division operation, the A is going to hold the quotient value, B is going to hold the remainder value. Now the question 4A, write an assembly language program to multiply the number present in external memory location 800AH and 8050H. Store the lower byte result obtained in R0 and higher byte in R1. So this is for 8 marks. So basically we have to perform the multiplication operation, and the criteria here is both memory locations belongs to the external memory, not internal memory. Therefore, we have to make use of the DPTR in order to fetch the data and as a memory pointer. So first DPTR is being loaded with the required memory location. Then first data will be moved, and then that value moved to the accumulator is stored to the B. We are taking the second memory location, fetch the data from the second memory location, perform the multiplication operation. So once you multiply the values, the result will be available in A and B only. So store the A value to the R0 as per they have asked, and then store the contents of B to the R1. So this is what has been asked in the question, and the same has been written. So try to understand the program in a simpler way. Now the 4B, explain the role of call and subroutines in 8051 microcontroller programming. Give an example. Now first we have to make a theoretical explanation about this call instruction. So that is being done over here. So what happens when a call instruction is going to happen? So that is being represented through this diagram. The same has to be explained theoretically also. Second part, the theoretical explanation has been done over here. What happens to the stack as well as what happens with the call instructions being done to the program counter. Everything is being theoretically explained. Now types of call instruction we have explained, and a small example of the call instruction. It's a pseudocode, not an executable code. A simple pseudocode you can take of any kind of example you can have. You can perform any data returning operation or addition, multiplication, subtraction, any kind of example you can take, and it's a pseudocode, not an executable code. So that you have to again make a explanation if possible with the help of the comment saying that what we are doing in this particular example. Now 4C, if the number A6H is placed in the external RAM between locations 0100H and 0200H, write an assembly language program to find the address of that location and place the address in R6 and R7 registers. Here what we have to do is, see, the value A6 is stored somewhere between this memory location. Now we need to identify in which memory location it is being stored. And we have to identify that memory location and store the location or the position in these two registers, because the memory location is of 16-bit and these registers are of 8 bits. Therefore, the 16 bits will be split into 8 and 8-bit each, and that's what the procedure we have to make a follow-up. Now there are certain things that we have to just sort out, and where we are storing the values in the R6 and R7. R7 MSP we are storing, R6 is LSP we are storing, but it is not specified over here. You can have an interchange of that also, but it is being considered like this from our side, right? Now here is a small program we are going to have for this one. So the values, how many memory locations we are searching, and what is from where we are starting. So everything is being mentioned over here, and each memory location we are going to make a search. If the value to be searched matches with the value present in the memory location, it means we have identified that value. Then we are going to store that value to the memory location over here. And remember, program, it's not restricted with respect to this only. Need not to take this as the final program. This is just a program which can satisfy that criteria. Further, if you want, you can have your own way of programming methods. You just try to follow that one, and you can have that program also. So we'll again join with the module, further modules of module 3 and 4 in the next video. Thanks for watching.